So welcome to our session on Postgres tips, tricks, and gotchas. This is the third iteration of this presentation. First time I gave it was for the LA Postgres user group. They requested a presentation that would kind of cover people who had been using Postgres for a while and could use a few tips to make their lives easier, as well as people who are brand new. So right now, this is a good spot to be if you really wanted to be in the other room and go through the full 3-hour tutorial, but couldn't get Postgres downloaded on the Wi-Fi or whatever. So we will go through a number of those pieces. Also, if you have the paper schedule, this is not the originally scheduled presentation. This is a fill-in because of some cancellations that we had. So really quickly, I'll introduce myself. My name is Darren Douglas. I'm a chief instructor of PostgresCourse.com. That's basically me and 2 other guys that teach Postgres, and we really enjoy doing so. I've been using Postgres since 2008, roughly. So that's 12 years of using Postgres as a primary database that I work with. Like a lot of people, people end up as accidental DBAs. You're the only person that knows Linux, and that's the only platform that this particular database runs on. So now it's your job. I see a lot of people nodding and smiling. So that's basically what happened to me several years ago. So the point of this presentation is to essentially, over the past several years of teaching Postgres, I found that over your typical 3 to 4 day administration course, there's a certain point where you can tell people have some type of aha moment. They've built enough of the core basic concepts that now everything else is smooth sailing basically through the rest of the course. So I'm covering a few of those things that we normally do in about a day and a half. We're going to try to cram it into about 45 minutes. That's the goal. So more stuff about me. A few places where I've used Postgres is specifically, I first used it in mining. So when I say mining, I worked for a company that was a technology startup in the mining industry. So coal, gold, copper, mining, right? So when things like that, you have a lot of operations optimization data, a lot of machine-to-machine communication, as well as a lot of GPS signals, mineral qualities, and things like that. And since then, I've continued on to do software development consulting. Right now, my consulting business, we're doing a lot of Shopify backend work for e-commerce sites, doing transitions from other platforms to Shopify, a lot of API work, things like that. In training, train people from a lot of companies. I highlighted one because it's kind of ironic, but we have trained at least 3 people from Oracle that needed to learn about Postgres to support clients, as well as every DBA at the Library of Congress went through our course, and that's it. So the point of the presentation, now I'm done talking about myself and introducing myself, is this. There's a few things that sometimes we're just so busy getting into a production issue or trying to get this new database that we're going to use for this project working, that we're doing things the hard way and we don't know it. And so I'm going to try to eliminate some of those things that we're doing the hard way, or some things that once you understand these core concepts will make Postgres a lot more pleasant to work with, and you'll become one of us who find it our favorite database to work with. All right. So we're going to break those down into the 3 categories in the title of the presentation. The first is tips. So a few things about Postgres DBMS architecture and operations. When I say architecture, I'm not talking about real internal architecture. There are people in this room that are qualified for that. I'm not one of them. All right. What we're talking about is the structure of a Postgres database, structure of a Postgres cluster. What does the concept of cluster mean? Once you understand those things, and once you start reading the documentation, a lot of those concepts become more clear, and it's a lot easier to work with Postgres once we get that baseline. All right. The second thing is tricks. So there may be a way that you have been working every day if you're new to Postgres. Let's say you've been working in SQL Server for years. There's a way you're used to working that you may try to bring to the Postgres environment that may actually cause you a little bit more pain than necessary. So I'm going to show you some things that Postgres, especially the P-SQL client, can do that will make your life really easy. And the last thing is a few gotchas. A few challenges that you're going to frequently encounter, just 1 or 2 things that if you knew this, or if I had known it 10 years ago, would have saved me like half a day of debugging because I didn't know what I was doing. So those are the things that we'll go through. Just a quick show of hands. How many of you are relatively new to Postgres? Been using it for a year or less? Awesome. Well, welcome to the community. Let's get started. So what I'm going to do is I'm going to just demonstrate some of these concepts and topics and introduce you to a few of the executables that you'll find on a Postgres system. So I've got two terminals open. On the left, I'm going to call it node 1. That's where I'm going to do most of the work. On the right is node 2. And there's a few executables that you may be used to that you use with Postgres. One of them would be pSQL. That's our client utility. And one thing that is really good to understand about the Postgres environment is this. So I'll just do this. I'll just determine where my pSQL client is living as well as my initDB. All right, so let's go to the path where initDB is.
You're a little bit off screen on that.
Yeah, what? Oh, thank you. Better? So let's take a look at that path. So I'm going to switch over to the Postgres user. And I will go to the path where those executables live. All right, so this is a directory that has all of my Postgres executables. And I'll actually make this window a little bit smaller so that we don't get problems seeing the back. All right, so one core concept to understand is that most of the things that you're going to install with your typical Postgres installation, if you just sit down on Linux server and say install Postgres and you install the way as directed on the website, there's going to be primarily a number of applications that get installed. The biggest thing you can understand about these is that almost all of them are client applications. The one that is actually running the server, you can kind of tell just by doing a quick listing. So this executable right here, it's the largest file in the directory. It's named Postgres. That is your server executable. Almost everything else in here is a client. Almost everything else in here is a utility that's used to either interact with the server, to initialize a new database cluster, or to perform other operations. Now, you might say, why am I emphasizing that so much? Once we get down the road a few slides, that's going to make a huge difference once we understand that. All right, so that's our Postgres executable right there. So if I were to try to use this executable, it's not something you're going to do a lot, but you could actually call this directly. A lot of people don't know that. So if I were just to try to execute the Postgres executable, immediately it tells me why it can't run. All right. So the reason why I point this out is that because a lot of people don't know I can actually directly call the Postgres executable, there are a few rare situations where I may have a startup issue with my cluster and things are not showing up in the log. So if I end up in that rare situation where I'm having a startup issue with my database cluster and things are not showing up in the log, I could simply execute the Postgres command and then everything's going to come to standard out. So in this case, my issue is that I already have another cluster running on the same data directory that I'm attempting to run right now. So in day-to-day life, that's a good technique to know. I keep on using this term cluster. Right? So typically when we use the term cluster throughout technology, what are we talking about? How many machines? Typically, when we say more than one, right? And that is a huge thing that some people have to try to break once they come to this environment. When we say cluster, when we're talking about Postgres, we're not talking about more than one machine. We're not talking about more than one instance necessarily. Instead, a Postgres cluster is defined here. If you look at the documentation, there's three things that define a cluster. It's a unique combination of IP address, TCP port, and a data directory. So essentially, we could take the word cluster anytime you see that in the Postgres documentation and replace that with instance. Think about an instance of Postgres. So a cluster is not multiple Postgres working together, it's one. Right? So there's really cool implications to this concept that we're going to get to as we move forward. All right. But let's just go back a slide. I have a few commands that I can use to work with a cluster. initdb is the one that I use to make a new cluster. So remember those three things. We need a TCP port, an IP, TCP port, and a data directory. So I can take essentially any directory on my system, and by running the initdb command, I can initialize it and prepare it for Postgres to run a cluster using that directory. So I'll demonstrate that in a minute. Actually, let's just do it right now. So notice I just tried to start Postgres by calling the Postgres executable. It said, hey, there's already a cluster running. So what that would mean is that I already have an instance of Postgres running on this machine. Let me try to connect to that real quick. And there it is. So I type in the PSQL client. That's the client utility. It connects to my cluster. In terms of connection information, there's a lot of ways we could connect to multiple clusters, whether on this host or another. But in this case, I'm just accepting the defaults. Try to connect to a cluster on the local machine, so the local host address. Try to connect to the default port, 5432, and try to connect as the current system user, which is Postgres. If that system user exists inside the database, which it does because of the first initialization, then I will be able to connect. So you can see I'm connected there. I do a quick listing, and I have a few databases, which we'll talk about in about 10-15 minutes. And I have one that I created called Baltimore, which we'll also discuss. Okay? So that's my cluster that's currently running. One way to understand the concept of clusters is this analogy that I've heard a lot of people use, I've used before, is that to understand this idea of cluster not being multiple machines, it's just one instance of Postgres. Think about a cluster of grapes. A cluster of grapes is a single entity, right? But attached to that one single cluster of grapes, you have multiple pieces of fruit. So the concept of cluster really comes from the concept of a database cluster. A Postgres instance contains multiple databases. That's the cluster we're talking about. It's a cluster of multiple databases, not multiple machines or instances.
Are there multiple databases or multiple tables?
There are multiple databases.
Multiple table spaces, right.
There can be multiple table spaces as well. So those are three separate concepts in Postgres. Yeah. All right, so let's go ahead and initialize a brand new cluster. So just to make my life easy, I'm going to become my root user. I'm going to make a directory called opt cluster A. Oops. And I'm going to make the Postgres user and group the owner of that new directory. All right. So if I look inside my opt directory right now, I have a single directory, cluster A, owned by the Postgres user. Look at the permissions. We're working with 755 permissions at the moment. So let's see what happens when I run initdb. So I'll switch back over to my Postgres user. And I'm going to run initdb. Remember, initdb is the command we can use to initialize a brand new cluster. So essentially, right now, this directory is nothing but an empty directory, right, that I created by the root user on the system and assigned it to the assigned ownership to the Postgres user and group. Once I run initdb, this command attaches to that directory, changes some permissions, which we'll see, creates some subdirectories, which we'll take a quick look at, and then does some additional configuration. So let's go ahead and take a peek at what we see inside there now. Oops, don't want to do that. All right, so that blank empty directory that I previously had, that I just created, now looks like this. And I have a bunch of stuff. A few things that are critical for you to know about, which we would go through every single piece if we had the full 4 days to teach you Postgres, are 2 files and then a common question that people ask. The 2 files that you really need to be super aware of is, number one, PostgreSQL.conf. That is where the majority of all of your configuration goes. So if you're talking about replication, backups, all kinds of other things, those are going to be configured in PostgreSQL.conf. That is that's a file with hundreds of lines that do configuration. If you ever have an opportunity to attend a session that is this PostgreSQL.conf line by line, those are awesome presentations. I highly suggest you attend one. But that's the majority of your operational configurations. The other file to know about is pghpa.conf. HBA stands for host-based authentication. So this is where we are able to configure which clients can connect to Postgres and how they can connect, and also where we can deny those connections. Also, if we're going to connect to some type of directory service, this is where we would define how that directory service interacts with Postgres. All right? So we'll take a look at both of those. We'll make some minor changes to those today. Then, of course, the biggest question that people ask when I start to introduce this as the data directory is, okay, where's the data? All right. So this subdirectory you see here named base, within there, once we start to create databases, beneath there will be individual directories, one directory per database, that the actual data is stored in, okay? But the really cool thing that I like about this is actually an elegant design point, which is what I said, we're going to talk about the implications of the definition of a cluster. Because my configuration and my data live in the same spot, let's say I have some catastrophic failure in my system. This is the concept of physical backup with Postgres. As long as I backed up that entire data directory, right, and it's off the machine somewhere else, then if I need to restore that database, along with all the settings of how it operated, along with all security settings, things like that, I basically just put that data directory back on another machine and I'm back. Not just data and configuration that was in that data directory. Does that concept make sense?
And at whatever time that picture was taken, of course.
That's correct. That's correct. Yeah. Good. All right, let's talk about those databases. I said we would connect to a cluster and we would look at what's inside the database. So let's connect to a cluster.
One other quick question.
Yeah.
Regarding base. Suppose your database is IO bound. Then can you like Oracle got all kinds of configuration options for putting things in different disks, right? Is there, I guess you would strike, right? Do some kind of RAID for the /base, or can you variously configure your database directory such that it's hosted on faster IO?
Yeah. So there's a number of ways to do that, either at the Linux system level, or you could do that by putting data in various table spaces and assigning those to the type of storage that you're looking for. So let's take a look at this. Right now, I have not actually yet started this cluster, right? And so let me just do that before we start to look at those databases. So another client utility I told you exists is called pgcontrol. So we just tell pgcontrol, look for the data directory called opt cluster A, and let's start it. And I get some failures. The reason why I get the failures is that I actually already have a Postgres cluster running on another port. So let's go ahead and fix that real quick. Remember I told you that the majority of your configuration is going to live in that PostgreSQL.conf file. So let's see if it has a setting for which port it's running on. It does. By default, it's running on port 5432. So I'm going to change that and tell it to run on 5433. And then I'll try to start my cluster again, and successfully it says server started. So again, just very simple configuration changes like that, such as what TCP port we're running on, all the way to configuring things like streaming replication or both, all within that file. Well, I'm going to go ahead and connect to that default cluster I discussed. All right, and here are my databases. In some DBMSs, you have some databases that contain a lot of configuration and that you're never supposed to touch because they are sacred. All right. That's not the case with these databases. When we run an initdb on a brand new cluster, we're going to see 3 databases that show up all the time. Those are the Postgres database, template 0, and template 1. All right. For years, I worked with Postgres and never asked myself, what are those for? And you're laughing because you are too. Right? So Postgres, let's start with that one. We might think, coming from other database environments, okay, that's got to be super important. That must be where all the users are. There's got to be super critical stuff in here that I'm never going to try to connect to that because it's named Postgres and I'm running Postgres, so it's dangerous. That's not the case. What it is according to the documentation, this is essentially a place for a client to connect. That's the number one purpose of that database. Remember the concept of cluster. Because we have a cluster, the cluster is a database cluster. So the concept when we're working as a client in Postgres is we never actually connect to the server or to the instance. Instead, we're always connecting to a database. So because of that concept of how it works, we need an initial place to connect, and that's the purpose of the Postgres database. It gives us our initial database to which we can make a connection, and then from there, we can issue commands that will create other databases. We can issue commands that will create global cluster level objects like users, but we still need a place to connect. And that's the primary purpose of the Postgres database. Now some people get started and they start putting data in the Postgres database. I wouldn't, but I have seen production instances where people didn't know what they were doing and they kind of started putting data in there. You can work with it, it's a regular database. But then someone who is used to Postgres comes along and they don't expect anything important to be in there, they could do something that would not be good to your production data. Another thing about that is, I've actually experimented with this. If you drop it, nothing bad happens. Your default connections won't work because it won't have that default connection point. But again, there's nothing critical in there that you can't live without. If something bad happens to it, you can just create another copy from a template. All right. So let's talk about those templates. Template 1 and template 0. All right. We'll talk about template 1 first. Template 1 is a really cool place to put common configurations that you would like to show up on any new databases that you create. I'll demonstrate that in a moment. But if you take a look at the create database command documentation on the Postgres website, I refer to the documentation so much because the documentation is actually excellent. What it'll tell you is that under the covers, what's happening when you do a create database command is without manipulating other options, which we have, if you just type create database, then essentially what's happening is a copy of template 1 is made and then is renamed. That's all that's happening. So let's try that. So I will say create database test 1. All right, I'm going to connect to test 1. And it's an empty, clean database right now, right? Nothing there. That's because at this point, that's what template 1 looks like. If I connect to template 1 and make changes, then those changes will occur in any subsequent databases I create. So let's demonstrate that. So I'll connect to template 1 and I'll say create table Darren single silly trivial table with my name on it, all right? So now within the template 1 database there is a simple table named Darren, all right? So now if I create another database, and let's just connect back to Postgres database just so it's clear that this is not being inherited because we're inside template 1. Let's say create database test 2. If I connect to test 2, that table shows up. All right. Yes?
What are schemas in this Postgres world? Because we've got clusters, we've got databases, right?
Yeah, so that's going to take me a little bit off track if I address that now. So let's talk about it after. But it's a good question. It's a very common question, especially with Oracle experts coming. Yeah. So here's my list of relations for test 2. That Darren table came from the instance I created in template 1. All right. So the idea here is that let's say that there's a number of utilities that we built. Once you get used to looking at a lot of the system tables and system catalogs, you may build certain utilities or views that you commonly need to know for your data set that are good for various measurements or development activities. You could start to load those up on your test or development server and put them all in template 1 so that anytime you guys create a new database, those views or utilities are always there. Right? That's the concept of template 1. So again, database objects that we want to show up in any database that we create from this point forward, we can put them in template 1. Now, let's say that I really mess up template 1. What do I have? That's the whole purpose of template 0. Template 0 is not for us to touch. So of all of these, I would not have expected that that would be the one I shouldn't touch. But the idea of template 0 is that it is truly a blank database. So when we start out with a new cluster, template 1 and template 0 are identical. Template 1 is the one we can modify with our own customizations, and template 0 remains that empty, blank, pristine database. All right? One production type usage that you'll see, and you'll also see this in your backup and recovery utilities quite frequently, is that because template 0 is blank, then walk with me through this scenario mentally. Let's say we start building a database, we put some objects in template 1, we create a new database, and so those objects show up in my new database, right? Then we start putting more data in there. I take a logical backup of it, and then one day I need to restore it. Well, if I say create database, a new database to restore to, if I say create database, then it's going to still have those objects from template 1, and then when I restore from my backup, because those objects exist in both places, I'll start to see errors and collisions, and you may have seen that before. So that's why the best practice is if we're going to create that database for restore purposes, we create it from template 0, then it's a clean blank slate with nothing there. All right? Incidentally, there is a way to force ourselves to connect to template 0, but it's not a good idea. Just don't do it. All right. This is a good spot to just show you a little bit of what PSQL can do. My first question when I started to sit down and work with Postgres was, okay, where's my GUI? And that's very common depending on what database environment you're coming from. At the time, I spent most of my time in SQL Server. I'd done a lot of Linux administration from a database perspective. Most of my time was SQL Server. So I was looking for a big set of utilities and development environment and all that. Because a lot of people have that tendency, they tend to overlook PSQL and don't realize how much it can do. So I just want to demonstrate a few things that it can do that are really cool to see once we get the idea that it's really primarily a client application. So one thing I can do is I'm going to connect to the Baltimore database, and really quickly I'm going to import some data. All right. So now I have this single table in the Baltimore database called employees. This is public data I pulled actually from the city of Baltimore. It's really nothing impressive. We take a look at employees. I don't need my node 2 yet, so I'm just going to widen this so it's a little bit easier to see everything. All right, so basically we have general HR information. We have people's name, their annual salary, their job title, their agency, and so on. All right. So let's say I wanted to find all employees that work for the city of Baltimore who have my same name. Select star from employees, where name like. All right, so that should be a list of all the Darrens that work for the city of Baltimore. One thing that we can do really easily with Postgres is manipulate this interface. If we're not used to working with databases using a text or command line based client, we might not realize that there's a lot of ways we can change how it's displayed. There's a lot of options in here. We could actually have it take this table and create an HTML table straight out of this output. I've done that once or twice. But what I do more commonly is just use some of the switches and toggles that exist within the PSQL interface. For a complete listing of them, it's \?. And then also, next door, Jennifer has a lot of nice resources for some additional switches, like the most commonly used ones. But if you just type \?, it'll show you all PSQL command line options and interactive commands. So I'm going to just really quickly demonstrate a few. So let's pull back my select, and then I'll do \A. As humans, we like to see stuff lined up, right? So if we take a look at this display, all of this white space is artificial, of course, right? This is not part of the person's, all the white space has been inserted so that the lines line up. If I type \A, the output is now going to be unaligned. So if I issue that same query, Now everything's squished together, right? I don't like how that looks, but now let's think about where do we want the white space to disappear? Let's say we're going to manipulate a flat file, and we're going to export this data into a flat file. I don't want white space unnecessarily, right? So by doing the \A, I can turn that off. Many of the switches that you'll encounter in P-SQL they actually behave as toggles. So if I do \A again, it'll just switch it back. All right. Now also, at the end of each time I've issued this query, I have a little bit of metadata. Up at the top, I've had the column name, and down at the bottom, I've had a summary of how many rows were returned, right? It's also possible that I could turn on timing, and I could have timing information for how long it took for that query execution. Let's get rid of that. So \T will now only return me the actual row results. So now you can see there's no header on this, and my summary at the bottom is now gone. If I type \A again, now it's unaligned. Oops. It's unaligned, and now I have only the data, all right? Okay, so let's talk about a flat file. What kind of delimiters do you guys like? Tabs? Okay. I hate commas, because commas occur a lot in my regular data. What never occurs in my regular data, especially on e-commerce systems, is a pipe. I never see them on Shopify backends or WooCommerce. They're just not there, ever, right? So let's say I needed a flat file export of this. If I do \O, I can tell Postgres stop sending, or I can tell P-SQL client, stop sending my output to my screen. Let's send it somewhere else. In this case, I'm going to send it to a file, which will be temp out.txt. So now every query I issue from here on doesn't come to my screen. It just goes to the output location I told it to send it to. All right, so let's see if it ended up there. And there it is. So just think about that. If I'm shying away from using this P-SQL, this weird little command line utility to interact with my database, you can see that just with 3 quick switches, I can do something pretty powerful. 3 quick switches, even though there's other better ways to pull larger database dumps or larger flat file dumps, such as the copy command, with 3 switches, which was \A, \T, and just leaving the default delimiter of the pipe, I have a pipe delimited file output to a directory that I designated. Pretty simple. All right. All right. How am I doing on time? Got about half hour. All right. Also, remember what we said about the create database command. So really quickly, one other thing I wanted to mention when it comes to kind of giving yourself a safety net during your development operations, could be a couple of things. If we're working with a small development database and pgdump is more than adequate just to pull a copy of a database and make it safe while I continue doing my development efforts. Another way I could do that, though, would be with the template command, and that looks something like this. So remember, create database makes a copy of template 1 and then renames it. All right. Now, I've only talked about configuration and structure so far because I just had that empty table inside template 1 at this point. But if template 1 actually had a full load of data, that would be copied along as well. All right. So in development, what I will often do is something like this. So let me connect back. Create database, Baltimore 2, template, Baltimore. I'll connect to Baltimore 2. So essentially I said the create database command, instead of using template 1 as the template, use Baltimore as the template. And what it'll do is it'll create an exact copy of the Baltimore database. Now, the only reason I don't do this in production is because the documentation says not to. But for testing and development, I do this all the time. All right. It's a really quick way to get a quick copy of a database and just start working with it as for development purposes. Now remember, I had to load the data into the Baltimore database, and if I just do a \D, there's the table for employees. And there's the data, all right? And that was just by me saying create database, Baltimore 2, template, Baltimore. It's almost like saying create a new database, name this, use the source or your origin as the one designated. All right. Just in interest of time, I'm going to come back to transferring databases between instances without file transfer because I think that one's less useful than it used to be, just in a world of a lot of virtual storage. So I will come back to that one if I got time. I want to get you to these gotchas, all right? So we covered the tips, which is the basic organization of what you'll see when you're working with a cluster, understanding the concept of cluster, the term of cluster, how to create a new one. I gave you some tips. Now let's talk about some of the gotchas. How many of you have touched the pghp.conf file? All right. How many of you like kind of banged your head against a wall for a while the first time you touched it? Yeah, all of us. All right. If you just remember the simple rule that is in the documentation that I ignored too the first time I worked with it, is that the pghp.conf file is read from top down. If you remember that, then it'll eliminate probably 50% of any issues you have with that file as you're configuring it. Let me demonstrate that real quick. All right, so at this point, this is what we'll talk about tomorrow in my presentation about just simple security things we can fix. I'm gonna go to my PG data directory and let's take a look at my pghp.conf. So if I just do a basic initdb, then this is the type of file that's created for my initial pghp.conf. Notice everything is wide open, everything's set to trust. That is not what I want. So again, tomorrow, if you'd like to attend that presentation I'll do, we'll talk about all the things you need to do to get a cluster from initdb to something that you won't get fired for. All right. So let's go ahead and change this. Let's just demonstrate this concept real quick. So let's say I just wanted to, don't tell Jonathan because I know he just told you to use Scram. But I know how these clusters are configured, so I'm just gonna say MD5. So now, by that rule, I'm saying I want all my local connections to connect, to be authenticated through MD5 authentication. So I should get prompted for a password now. So I will say pSQL. And I'm not prompted for a password, right? What's that? Oh, that's true, absolutely. No, you're right. No, you're absolutely right, thanks. I got reloaded. Duh. All right, so I'm gonna reload. I can still get in, which is problematic. So let's take a look back at that file and determine why. Remember, it's read from top down. So the very first match for any connection attempt will be honored. So if we start with this first line, is this a local connection? Yes. Okay, trust it, let it in. It's over. So because it's reading from top down, the first match is honored, stops reading the file, and then whatever action is defined by that line is honored. So let's go ahead and move these around. Let me just get rid of that one. Make another copy. I'll put the trust below now. I will reload my cluster. And now let's try to connect. And now I'm prompted for password. All right, so just something that simple, the order of the lines. It's not a matter of whether or not the line exists in the file. Order is very important, all right? So that's one thing that can eliminate a lot of headaches if you're trying to get that configured.
Does that also mean essentially that second line will never come into play?
In the case,
Can you cancel out of MD5 and get inaccurate trust?
in the case of this trivial example, that we would never hit that, right? Because it's trying to match these first three. So a local connection through the local socket by all databases by any user, because this is exactly the same, it would never hit that second one.
So it doesn't fail and fall through.
Right. Yep. Whatever the first match is honored. Good question. One other thing that I think is an interesting gotcha is I told you that primarily I'd done some MySQL, but I worked with a good amount of Windows SQL Server before coming to Postgres. And one thing that I noticed some developers did in T-SQL would be to enclose object or table names in quotes. Also, I noticed that a lot of utilities for migrating out of Windows SQL Server to other databases also enclosed object or table names in quotes. Not a good idea in Postgres. So let me show you why. Or at least, let me change my hpa.conf back so I don't have to log in. So let's connect to our test database. All right, so right now I have no tables in there. Let's say create. I'm just going to do those same create table commands you saw me do before. So create table. I'm going to put a capital D here, right, for my name, Darren, and I'll say A int. All right, so one single column, create table Darren, \D. Notice what it did with this case sensitivity. It's just discarded. It's not honored. Let me put some quotes around that. So in this client, by putting object names in quotes, I'm essentially telling Postgres that I do want case sensitivity to be honored there. All right. So by doing this, then anytime I query against that table, now notice if you would think there might be some confusion if I say select star from Darren, you might think, well, it's going to say, hey, which one? But it's not, because it's going to the one that is not defined as case sensitive. Or even if I do this and I put a capital D on it, again, it has no confusion about which one to select, because by not enclosing this in quotes, I'm not telling it to honor case sensitivity. All right, and we can demonstrate that. Let's just toss some quick data into it. So insert into and then I'm going to do a mix of capital and lowercase. And then I'm going to do this, the one where case matters. All right. So in the first two, because I'm not including quotes in my SQL syntax, select star from Darren, everything's downcased. Let's grab the one from the one where we weren't told to honor sensitivity in the object name. All right. But in the one where I include the quotes, that still remains an empty table.
That's a very good point. I have a challenge with my developers. When they do uppercase double quote, don't do the double quote. Use only
Yep. Just put the object name in it. Don't need to quote it.
quick thing for one other person's problem impacts. If you use any framework for, it'll always do it by default quotes. So if you use their migration stuff.
Which tool is that?
Any framework?
Okay. Like I say, there's a reason why I mention it in a number of presentations, because a lot of utilities end up doing that, just putting quote names around objects. And it can create a nightmare, because I had a project where another developer was new to Postgres and he started creating tables, and like I'm still living with a table that I have to always include in quotes, and it irritates me. It really bothers me. That next point, debugging startup issues if you don't like tailing logs. That's basically what I showed you at the beginning. It is a cool little trick to just call the Postgres executable if you have access to it. And then if there's anything that would not show up in a log, or you just want the immediate output, everything's going to come to standard out by default. And let's play around with one more Postgres setting, and that is just log settings. How many of you are working with some environment where you have an ORM framework that is actually doing the real communication with the database? Yeah, so SQL Alchemy, Active Records, stuff like that. Sometimes we'll have some code that we wrote, and under the cover SQL Alchemy, Active Records doing its thing, and it's querying the database. And I'm wondering, why is this taking so long? What did it actually tell my database to do? Did it tell my database to do it the right way? All right. So I was kind of working, I do a lot of Python and Flask, so I was working with Python, Flask, and SQL Alchemy. I'm banging my head against this particularly slow responding piece of the software. And I'm like, okay, SQL Alchemy, tell me what you're doing. Tell me what you're doing. And I realize I don't have to ask SQL Alchemy what it's doing. I can just look at the database, right? So really simply, we could do something like this. Let me actually do this. So I'm going to configure Postgres to log every single query, which is not hard. And that may not be what you need in production, but in development, this can answer that question. So we have a section of the PostgreSQL.conf file that is about error reporting and logging. Again, in a full several day class, I'll go with you through all these settings. Well, let's just jump down to when to log, and this setting called log min duration statement. All right. So this can be tuned to whatever my definition of slow is, or it can be tuned to log everything. So if my definition of slow in my environment is half a second, I could just type in 500 there. Because it's defined as milliseconds, then anything that exceeds 500 milliseconds will be logged. All right? If I'm looking for slow queries. If I just need to know what that ORM is doing under the covers, I just simply change this to a 0. And as you can see in the comment to the right, it logs all statements. So anything that is issued against my database will show up in the log now. So I will go ahead and save that. Also, I'll just jump back in here. Also really well documented in Postgres is almost, really not almost, every time that there is a change that requires a restart of your cluster, it'll be noted. So in this case, it says change requires restart. That's not the setting I just changed. Because my setting in the comments did not say change requires restart, I can get away with a reload. And the concept of restart versus reload is restart actually stops and starts. Reload just tells Postgres reread your configuration. All right. So I'm going to get away with a reload here. Oops. And let's see if I can see if the internet will allow me to open another connection to this machine, since it's been really slow in here. Make that a little bit bigger so we can see my logs over there. All right, so here are my logs over to the right, right? Okay, so let's issue a few queries. So let's \c. Just from that command I issued, you could actually see Postgres the system catalogs because I was using the readline library to autocomplete. So you can actually see where it's actually hitting the system catalogs and saying, hey, this guy wants something that starts with Baltimore. Where is it? And now we can see the queries issued to do that. Once I connect to Baltimore, select star from employees. And now let's say, again, my ORM was doing something under the covers and I don't know quite what it was doing. Because I'm logging every single query being issued against this database, I would be able now to tell how it was executing stuff. All right? I think that's my time. Yep. So again, thank you so much for attending. If you guys have any additional questions, I got a few laptop stickers and some pins. And then I will see you tomorrow if you'd like to attend the security session as well. So thanks for your attendance.